This is part 6 of getting started with SPSS syntax, in which we look at a number of other useful syntax procedures. The first topic is introducing the to and all keywords, which allow us to apply syntax to multiple variables. Now, the initial problem that we're going to deal with here, we can illustrate in SPSS, where we have a number of variables that require value labels. In fact, they all require the same value labels because they're all rating scales with the same response options. And obviously, if we're going to write some value label syntax, we don't want to write the value label syntax over and over again for each individual variable. So the to keyword comes into play here, and it allows us to much more efficiently apply the same set of value labels to a group of variables in one step. So here we're going to use the value labels command, and we're going to apply it to all 7 variables in one go because they all share the same response options. Something which is important is that all of the variables occur sequentially in the data file with no extraneous variables interrupting the sequence. And that's important for the to keyword to work. And you can see here that the keyword works simply by saying value labels rate 1, which is the first variable, to rate 7. And it basically assumes that these variables are all going to occur in sequence and applies all of these value labels to the 5 separate response options, where 0 is don't know, 1 is excellent, 2 is good, 3 poor, and 4 very poor. Let's have a look at how that's done. And back in SPSS, here's our command. We're going to apply it, just highlight it and hit run. And we should instantly see the effect of that by going back to the data and switching on the value labels. And we can see that they've been applied correctly to every individual variable in one step. And just on a side note, you may notice that the value label don't know actually has double quotes around it rather than single quotes. And that's just because it already contains an apostrophe in the word don't. So double quotes helps us deal with that. Also of importance here is that we can apply the to keyword to analytical procedures such as frequencies. So we can say frequencies rate 1 to rate 7. Let's have a look at that. So we can apply the to keyword in the frequencies procedure here, rating 1 to rating 7. We'll just run that. And what we get, of course, are 7 individual frequency tables for each of the individual rating scales in one step. It's also worth noting that you can apply the all keyword to all of the fields in a file. So you can say frequencies all, and it will do frequency tables for all of the variables. And that looks like this. You can see we've got quite a lot of different frequency tables here, even though some of these are numeric or scale fields. The next topic we're looking at is working with scratch variables. Scratch variables are temporary variables that can be used as part of a calculation process. They generally tend to be variables that are used as an intermediary step, and the user isn't really interested in keeping them permanently as part of the file. So scratch variables are only temporary in nature. They're all prefixed with a hash symbol. Now the following example could be completed in a single step, but here it's used only as a simple example. You can see that there are 2 computes being created here. One is employing a scratch variable, and the other one's employing a permanent variable. Let's have a look at that in a bit more detail to see what's going on. In this syntax, the focus is really around the variable job time, which records the number of months employed by the organization, so the number of months that an employee has been working there. So the scratch variable years employed is simply job time divided by 12, which will give us roughly the number of years that they've been employed. So if we wanted to figure out what age they were when they started working for the organization, we could take away our hash variable, or scratch variable here, years employed, from the variable age, and that would allow us to create a new field, permanent new field called age start, what age they were when they started working there. There's an additional keyword here, an additional statement called trunc, and that just truncates the result to remove any decimal places. It just chops off any decimal places at the end. Once again, we're using our employee data. Here's our syntax that we've just talked through. It's creating a temporary field, years employed, which is used as part of the calculation where we take years employed away from the employee's current age to create a permanent variable called age start. Years employed will not appear in the data editor as it's a scratch variable. So we run that, go back to the data itself. There's age start, that's our new field. You can see that's a real field. Hit descriptive statistics on it. It says the mean age at which people started was about 28.3. Here it has no actual, it's all integer values. It doesn't have any decimal places except in the formatting. If we wanted to remove that formatting, we just go down here to type in formats, and it would be age start. Let me go F1.0, no, F2.0. And we can see that it just reformats it so the decimal places aren't actually displayed. The next example, a really simple but powerful command, delete variables. The delete variables command can be used on an individual basis, or you can apply it to a list of variables, incorporating the to keyword that we saw earlier on. Here it's just being used to delete two variables, birth date and previous experience. And here are those two variables present in the data editor. If we just go to the syntax here, we can run the delete variables command and get rid of them. Come back and they've disappeared from the data editor. Another really quick example is the rename variables command that simply changes the names of the variables. It can be applied to individual variables on a group basis, and it can also be used as a subcommand when you're reading a file using getFile, or you're saving an SPSS file using SaveOutFile. Here's two examples where we're renaming the variable JobCat to job type, and here's an example where we're renaming a group of variables in the list salary, beginning salary, and minority to current pay, starting pay, and minority group. Let's just have a look at that. Here are those variables currently displayed in the data editor. We can rename them using the syntax that we just talked about. Go to the syntax editor and run both procedures. There's job type, current pay, starting pay, and minority group all been renamed from their original variable names. I mentioned the keep and drop subcommands earlier in this series of videos when we were talking about reading data files. You can also use these commands when you're saving data sets. Keep and drop respectively allow users to either specify the subset of variables that they wish to keep or retain in a file, or the variables that they don't want to include. So in this first example, only the variables ID, salary, and beginning salary would be loaded, because it's saying get file employee data with age.sav, so it's reading this file, and it's saying just keep ID, salary, and beginning salary. And here in this example, we're saving a file called employee no salary.sav because we're dropping the two variables salary and beginning salary. Let's just have a look at that in action. So in this example here, I'm going to read a file employee.sav, but I'm just going to read four variables. I'm going to actually even name the dataset, give the dataset name emp employee for var. So if I just run that, there we read that file, and you can see that it's dropped all of the other variables. It's just read the ones we wanted to keep, And lastly, in this section, we're going to introduce the output modify command. So this is a very powerful function which allows us to apply formatting and other changes to the contents of the active viewer window. So it's useful if you want to automatically delete unwanted objects like warnings or syntax logs that are appearing in your output and messing up your output. You don't want that in there. But it also can be used to highlight specific types of values, such as totals in tables. The following syntax, for example, deletes all preceding output except for tables and charts. So it will get rid of titles, it will get rid of warnings, it will get rid of everything else apart from something which is either a tabular piece of output or a graphical piece of output in the form of a chart. And just to illustrate that, I'm just going to create some output here in a blank output viewer. Just going to create some frequency tables for the variables job, cat, gender, and minority. Click that. You can see there's our frequency tables. We've actually got some additional stuff here. We've got like a title. We've got another title up here. We've got some notes which are hidden. Actually switched off, but there's a notes. It's a statistics table. So if I run my output modify syntax here, you can see it's basically saying clean up output, select everything except tables and charts. That's what that's saying. Select all except tables and charts and delete the objects that have been selected. So if I run that, you can see now that all of those additional elements have disappeared and we're just left with the tabular output. So it's kind of cleaned up the output viewer for us. And lastly, one more example of the output modify command. The following syntax will find frequency tables in the output viewer and emboldens the total values in each table. So this is output modify, where we're actually asking it to look for a particular type of object. You can actually get the search for any sort of object that's given a label, whether it be a crosstab or descriptive tables or anything like that. In this case, it's looking for frequency tables. And it says find within these tables the element total and apply the style bold to that on a row basis. So it's going to, if there's a total appearing in the row, it will embolden those values. Let's have a look at that. Now all that remains is for us to run this additional output modify syntax on the 3 frequency tables that we have in our output. We've got a statistics table here which it will ignore, and the 3 frequency tables have at least 1 total dimension on the rows of each table. There's actually 2 totals here in this table and 1 total here, and it should find those elements and embolden them if we run the syntax. Let's have a look at it. And there are all of the totals in the row dimensions actually emboldened for us.